So other than your group leader here, I think One-Ling, you've come to a few lunchtime sessions. Jane, you came to a few. Lily, you're new and maybe haven't come to, you came to one, right?
Yeah.
So Byongi's definitely the one who's come to the most. And I think what I'm going to do is I will frame a lot of what we're going to talk about today in trying to let you guys know why it's important, the smiley faces that we've been doing. Some people have made the comment that, you know, it's kind of abstract concepts, and it's like, why does this smiley face affect my job? And what we'll show today is that to do these kind of useful things, so Byongi's come to me and he said, one of the things that we spend our time on a lot, on a couple different things. One would be getting the moment of inertia out of a diagram that someone else has sketched up. The engineer obviously needs the moment of inertia for calculations. Equally, a section. Now, One-Ling, you've sent me this. Am I right to assume that something like this is a good example? Oh, perfect. All right, we'll use this as the example. So something like this might be sketched by, you know, a drafter or something like that, but the engineer needs to get out a moment of inertia. And we spend some time every project, or multiple times per project, trying to go through and figure that out. The problems he's described to me are problems that we can solve very easily. Having said that, it's assuming that you know a little bit about the background to computation and why, for instance, this matters. Chapter 1, the smiley face examples, why that matters. So we will keep that in mind. So what we'll start with is does everybody remember, first, I think you've all done lesson number 1, where we said, what's the biggest thing to do when you're doing computational engineering? Where does computational engineering start? No. The smiley face is just an exercise. We had said the biggest, most important thing in the world is to start on paper, right? That was our main thing. And we had started with this concept, and I'll blow this down a little bit here. We had said that, yeah, go for it. Let's see if I can sketch. Oh yeah, we're good. We said on paper, and I'll use digital paper today, we usually start with something input, and we say we want something that's an output, right? So we have something that right now that has come from a drafter or whatever, and we said we want to figure out how to get down to what do we want here. And in this case, I think we said we want IX and IY, right? Is that a fair statement? Okay, so we had said that in computational engineering, one of the first things to do is we'll do this process a few times. And that version 1 of this process is going to be using English to describe from first principles, as detailed as possible, how we go from here to here. Okay? So let's do that. Step 1 in this process. What's step 1? Equally, we could also start from this side, and the good engineers maybe start from here. I want this. So what do I do to get this? And then start at, you know, step N, and then work our way backwards. But somewhere in here there will be a series of if for this to work, for the computer to help us, it needs to be that we come up with the set of do this, then do this, then do this, then do this. So if I was on the Facades team and I was a graduate engineer, which my facade skills are at a graduate engineer level or less, you would tell me, okay, here's what you need to do. What do I have to do? Step 1. Find centroid. Because we take the so we would say, I'm going to use this diagram here. So after step 1, find centroid. And next one. So what do I do next?
Build to plan. Build to plans.
Build to plan. What does that mean?
For, you know, it's IX and IY plan.
Build. You say build to plan. Build it in an area on a plane. Actually, I'll give you a hint. I know the answer, kind of. What's the last step?
Calculate it.
How do you calculate it? Do you pull out your integral tables and start, using calculus 3 on paper, starting to do stuff to get the moment of inertia? Do you do that? Or how do you literally get these numbers?
Relate this shape to some software.
Oh, that's fine. This is you use a piece of software. What
Yeah.
software do you normally use?
AutoCAD. I don't know.
AutoCAD, right? So we press probably, it's like properties or something. I forget what it is in AutoCAD. I haven't used AutoCAD for years. So we just, AutoCAD.
Mass property.
Yes, mass properties. And we know behind the scenes that what this is doing is some sort of integration from 0 to n of whatever the shape is, right? But we're not doing that. Like, we're just going to apply that theory via AutoCAD or some software, right? Because we know that we're not doing integrals. Okay, so at that point, we know we're working in AutoCAD, for instance. You've done find centroid. Most likely this step 1, again in a different color here, what would you have done? You would have said black, this find centroid, he creates this, right? Mass properties, what does that return for you? Ix and Iy, is that about the object's centroid? Is that about the global coordinates?
What about the central?
It's about the centroid, right? So it's not like we need, so we're already assuming that at this point where we're blue, actually the Ix, Ix and Iy are about these axes, right? So we don't have to do any sort of movement, parallel axis theorem, that type of thing, no? Okay.
Because what I said before, like I need to view 2 planes, is to define which axis is x-axis and which one is y-axis.
Right. So that's where we're headed here is, if I were to be a guy who was saying that these are the, let's say, the global axes, right? So these are the global axes. Right now, the picture, from my experience in using these types of software, the orientation is chosen by the global axes. But if I gave you a section that is like this, right, then what you're saying is that's going to give me some sort of weird moment of inertia that's going about, that's not how my thing is bending. My thing is bending, usually it would be about these axes here. And it's this theta that is now a problem, right? So what would you do to make sure, so there would be a step 2 or 3 to avoid that, which would be what? What would you normally do? Rotate to basically the orthogonal global coordinates. All right, so I'll put that in a different color. Rotate to global coordinate system, right? Find the centroid, rotate about that centroid to be parallel with some sort of global coordinate system, and then AutoCAD does an integration, and what comes out the back is a moment of inertias, right? That's what we would do. No surprises there, right? We're going through it as if we didn't know the answer, but this is the way we have to approach these problems, because this is what helps us, because this is an easy problem. The more useful we get, the harder it becomes, right? All right, so that's English. You would go up to the graduate and say, first of all, press the button to say find centroid. Second of all, rotate it to get the global coordinate system parallel to the local coordinate system. And the local coordinate system obviously is something that's an engineering thing. And third is AutoCAD, press mass properties, it does an integration, done, right? Now, when you have realized with the smiley faces that in order to get the computer to do stuff for you, it doesn't speak English. And it needs to be very, very specific, right? So if we were to do a second iteration of this, right, we would need to basically take this definition, which I'll save right here. So let's just say this is version 1. V1. That's the plan overall. Now, if I sort of start playing this game, and this is the game you have to play. So V2 is, okay, we're going to start playing this game. I'm going to play like I'm on the computer. And I say, really the big problem here now is I'm just showing you a picture of what this is. So let's pretend for a second that now we're going to put something here and we're going to say, these are surfaces. Just like in the chapter 1, all we've done in chapter 1 is we've said, you got frowning faces on every single one, but all we're doing in all these cases is we're changing what the data is that I've given you. To your face, it always looks like that guy on the left there. But in every single one of those files, you've been given a different piece of data. That information changes the way that you have to approach the problem. Not from a first principle standpoint. We still need to find the centroid and eventually get down to an integration that gets us the moment of inertia about that centroid around the right axis. But now I'm telling you, you have surfaces, right? And I will tell you one thing, you actually have, in this situation, I say surfaces, right? Because those two things right there are actually, I don't know in real life if they're connected, I assume they are. They act structurally together, but digitally, you have two surfaces, right? So you sit there and you say, well, AutoCAD, I can click on the two of those and maybe it does the math for both at the same time, right? But digitally, I have to now explain somehow to the computer how to do that math, right? So we know we have two surfaces, and there was another huge problem that Byongi had let me know that you guys have, which is those two surfaces may not be closed. Those two surfaces may actually be drawn incorrectly, things that look like, effectively, like it might look like it's snapped, but on the very microscopic level it's not. It could be that we have like this weird profile, and actually there's maybe two lines right here, and that screws it up, right? So it needs to be, it's not that simple. And also, if it was perfectly, let's say these two, that they were perfect two rectangles that snap together, I'm assuming you guys would have to select them both at the same time, and then hopefully AutoCAD does the math to subtract one for the other, or does it? How does it do the math? You would do the math. Yeah, you would do the math, right? So you're spending your time sort of jotting down, okay, it said this, and then you're going in and said this, and then you do A minus B, right? Okay. These are all things that are solvable, right? So what I want to do today is to sort of build up with you guys how we could do this to basically automate the process. Because what you're doing doesn't change, right? It's not rocket science. It's literally mundane stuff that if we can eliminate that, you get your time back and you can focus on what's most important, which is, listen, can I actually get the right section in here quicker? Because you know what you need to do. You need to make the section work, period. To putz around with all of these different technological issues, going into AutoCAD and pressing mass properties 50 million times, copying down a number onto a sheet of paper, that's not what you should spend your time doing, right? So when we say first thing, find centroid, right? Find centroid is kind of an interesting thing, because let's pretend that, again, let's boil this down to version 2 is two surfaces, and we'll just say that, we'll split them up into two like that. I don't draw it very well, but basically let's say surface 1 is over here, surface 2 is over here. So if I say, again, we're working now with a list of surfaces. If I say surfaces go in, we have a little component, which I can tell you we have, that says give me surfaces and I give you a centroid, right? What comes out of the back of this? In version 2, it's not going to be find centroid. Well, we have a tool that says find centroid, but we've given it two things. So what's going to come out? 2 points, right? If I give a little black box that takes in a surface and spits out a centroid, but I give it two surfaces, it will spit out two centroids. Well, that's not what we need, right? That's not what the first principles says. First principles, when we on version 1, we said we want this, period, right? If I split it like this, we'll probably get something that looks like this and something that looks like this, right? So now this is where the first principles, again, find centroid, gets impacted. This whole script, is this algorithm that we're developing here, is going to get impacted, because now, instead of jumping straight to a line with user coordinate system, we have to deal with this idea of, well, we don't actually have the centroid yet. We have to put in 1b here and say, do something. Again, now 2 points will come down here, right? 2 points comes down here, and what we want to come out is 1 point. Or can we make these into one surface up here, right? Something like that. So we have to get back to digitally, we're getting screwed up. But the first principles aren't changing. It's just we need to change what we're doing in the computer, right? Let's assume for now that we can't join these two together, because I've tried. You can't, because they don't actually connect to each other. If we inspect the data, and there's nothing wrong with starting on paper, but also sort of inspecting the data. You should get a good feel for what do you actually have. And in this situation, I would say, actually, I click on this, it says polysurface. And on this, it says polysurface. So I said two surfaces. I have 2 polysurfaces. And if I try and just say join, because that would solve all my problems, I don't get that. So I have 2 polysurfaces, full stop, right? So let's assume that's what we're going to have all the time. Now you're going to say to me, Medio, I might have a bunch of different types of data, right? I might have a polyline, I might have a this, I might have a that, right? We're going to learn how to do it easily first with something like this, and then we'll get up to a script that maybe can handle more. So something very simple to something that's more complicated. This entire task in general, to find the moment of inertia of this type of stuff, is a perfect example of stuff that, you know, you could easily work on this and get better at computational engineering skills if you don't like the smiley face examples, if that's too abstract for you. But I will promise you that you will be doing the exact same things, except for it will be a bit more difficult, actually, because this has been designed not only to be relevant, but to be easy. Okay, so you'll be doing the same things. So I suggest doing both, because they're both extremely important, especially this one, because it's about your job. All right, you guys with me? So first problem is that we are assuming in version 1, where we were just talking about things. I'll pull that back up. Details. Oh yeah. So let's remind ourselves real quick. We are assuming that what's not seen here in our thought process before was that we're assuming left is just one thing, and then we'll, have it all together. Because we're used to just sort of clicking it, and AutoCAD takes care of the rest of the business for us, right? But we know AutoCAD is not really doing we can't scale from AutoCAD. And the biggest advice I wanted to make sure to get out there today is, you guys are working in a 2D CAD medium from what Bianchi said to me. The best thing you can do right now to start moving forward and into the future, AutoCAD is what it is. It's the past. It's never going to be scalable. You can't do anything other than what you do, how you do it in AutoCAD. If you are using just 2D CAD, you might as well move into Rhino, and you will if you want to scale. So we will be working out of Rhino because Rhino has Grasshopper. Grasshopper is the portal to doing better things. You cannot do this in AutoCAD. It will not work. And the best thing you can do is just start getting used to a new CAD software. Like Rhino is exactly what AutoCAD is, except for with an entire new portal for you to improve your job. So the best thing for you guys to start doing is stop having that black AutoCAD screen up on the screen in front of you in your department and start getting Rhino on. Because it's the same thing, you'll learn it in a day, and then you will actually be able to scale, instead of just having to do click this, click this, click this, you can start to automate parts of your business. You won't be able to do it in AutoCAD. So, again, version 1 was just, if we were doing it in AutoCAD, we're in an AutoCAD state of mind, so in our minds we just grab things and AutoCAD takes care of the rest. If we want AutoCAD to automate more stuff than just, hey, Mr. AutoCAD, thank you for connecting 2 things together for me and making me manually type in mass properties and copy things down. If we want to move past that, we have to give up that, and we have to take responsibility for the fact that it isn't one thing, it's 2 things. Okay, so that's the thing now, is we are actually saying, well, sorry AutoCAD, thanks for doing that for us, but you don't do enough, so we're going to take the reins on this. Okay, so let's just before we move forward, just because, again, look, 30 minutes and we haven't even touched the computer. 30 minutes, we're at 60 minutes today, and like I said, this is the most important part, because if we can't do it here, then we can't do it in the computer, right? But let's just say, let's get down to 1B. What can we do to go from 2 points to 1 point?
Find the centroid of that 2 points.
Find the centroid of that 2 points. Okay, I like that. What does that literally mean, though?
The midpoint.
Ah. So if we have 2 points, you're saying 2 points can go to
1 point.
1 point via probably a line and via a midpoint of that line, right? Now, mathematically, if we were really NASA up in here, do we know for sure, is anybody really good at geometrical theorems and proofs and stuff like that, to say, if this is the centroid of the full thing,
Yeah, may not be.
it may not be exactly the same, but for the purposes of this discussion, let's assume that that's right. I don't, off the top of my head, think that that is. But then again, we're not NASA, so maybe it's good enough for government work. I don't know. We can always test it, right, or think. But let's say that's right. So Lily has said we want to go from 2 surfaces, or X amount of surfaces, to 2 points, or X amount of points, to, and I guess this wouldn't work. Your thing wouldn't work if we had 3 or 4 or 5 points, right? But for 2, let's just assume 2 points to a line, and then a midpoint and a 1 point. Okay? Everybody, let's get up Grasshopper. Let's go through this together then. And I'm going to pretend I'm you guys right now. This is the, what we're not doing in the class so much is hand-holding in terms of taking you through one thing at a time, because there will be there's a necessity for you to learn it yourself. Like, there's no way we'll make a class that can go over every component in Grasshopper, right? If you look up here, there's just so many things to learn that you will just learn them as you need them, which is why it's extremely important to do what we just did. Because now, our lesson for the day is, how do I take a surface into Grasshopper? That's step 1 here. How do I find its centroid to get 2 points? How do I take those 2 points and get a line? So what do we have to do? We have to learn how to get stuff into Grasshopper, stuff that we can see on the screen in Rhino, into Grasshopper. That's lesson 1. Now, I know some people in here are bosses at Grasshopper and they know how to do this very well. If I'm not around, Byongi's not around, and you know nothing about how to do that, where do you go for help on this problem? Help? Where is the help for Grasshopper3d.com? Where are all the answers when it comes down to simple questions about how do I get this from Rhino into Grasshopper? Grasshopper3d.com, right? Grasshopper3d.com, the Bible. If you can't come in here and ask the question, how do I take my facade mullion and convert it into the right moment of inertia? You can't do that because that's too much, right? I always use the example, my girlfriend's from Hong Kong, she doesn't speak English 1,000% fluently, and she'll always say, oh, did you design that pillar? You will not find on Google, if you type in how to design a pillar, any resource. But if you say how to design a column, you will. So a lot of this comes down to your Google, Baidu type of search skills, that you know what to search so that you get the right answer. So we might say here, Grasshopper 3D only, reference surface into Grasshopper. And that would be it. That would be the basic skill. I don't know why nothing's coming up. Oh, there we go. Reference geometry in Grasshopper. And that's the first thing that comes up, and it's exactly what we're going to do. I happen to know this because I've used Grasshopper for 7 years, but this is the kind of thing that, we'll get working together. You'll learn how to do this. A lot of you know it already, how to do this first step. But if you didn't know, that is literally the barrier to entry, is that you would just go and try doing the input-output board here that we've done, and then go Google search, how do I do the first step? If you didn't know this, you wouldn't have any chance of doing this solution at all. Because you'd be sitting here and you wouldn't have any, you want to break the big problem up into small chunks, manageable chunks. Okay? So to do this type of thing, if you guys follow along, these little hexagon emojis up here, those hexagon emojis are little data buckets. So this is a bucket which contains a circle. It will only accept a circle. If I'm a guy who tries to go and he puts out, I want to make a circle of 8 meters diameter, this guy goes, data conversion failed from number to a circle. Why? Because he is not creating a circle. A number is not a circle is what he's saying. He says, I'm a guy who contains a circle. You give me a circle, I give you the same circle back. You cannot sit here and give me a number, because a number is nothing to me. Okay? This is why it's extremely important to do, again, Chapter 1. Because all we're trying to do in Chapter 1 is understand, what does the computer see? You see something that says circle on it, and you assume if I give it a radius, he'll give me a circle. It's not how it works. So you have to be empathetic with what he's seeing. And again, Chapter 1 is all about, he sees 10 different things. You see the same thing in every single situation, right? You see a frowning face, frowning emoji. So all these black hexagons, they're just buckets O information, right? So that's a circular arc bucket. This is a box arc bucket. Now we said we had a surface, right? So if you look, there is going to be one. You can double click the canvas and type surface, and the black hexagon emoji comes up, right? And it says, again, contains a collection of generic surfaces. So we click that, and then what's the guy online telling us? He says you right click it, and this comes up, and you should be able to right click, set multiple surfaces, boom. Oops, enter. Oh, hey, because it's a poly surface, so he's taking the surfaces of the poly surface. So why is he bugging out? Why is he angry? Why does people think he's angry? Again, what do I actually have? We're making a mistake here. If I click on something in Rhino, it says up here, one poly surface. You've clicked one poly surface, Emilio. And what have I tried to bring into Grasshopper?
Just one surface.
One surface. Is a poly surface a surface?
Yes.
No.
No. Okay.
No. Poly surface there's no nice way to say no to do that one. No, it's not. That's the thing. Poly surface, multiple surfaces. So a surface can be contained within a poly surface, but a poly surface is not a surface. Just like some of you in some of the classes don't realize sometimes you're like, I have an arc. Well, an arc is a curve, but a line is not an arc, right? So all of these, well, it's confusing, but it's the way we should be thinking about the world, right? Because in that situation, we actually completely understand what we're doing, right? So we have to be very specific that a surface, again, what does the computer see? The computer sees ones and zeros at a very basic level. So the way it sees the world is very specific. And in that situation, he does not see a surface. He sees a poly surface. So I type in poly surface. You say, okay, media, I'll follow your instruction. The only thing that comes up is surface. So you go, oh, this thing's a piece of crap. Medio said if I use those emojis and I right click and I come over here, it should work, and it doesn't. So this stuff isn't developed, and I'm going to give up because it's not ready to go. This is one of the big things about this space, guys. It's been given away for free, completely for free, and every day more and more people give away stuff for free. The new rule, the new paradigm is when it turns orange, you don't get to sit there and say, it doesn't work, and that means that we shouldn't use it because it sucks. You have to say, it's my problem now to figure out why that's doing that. And that's the way things are going to start happening very quickly in our industry. You see it. People are just taking responsibility. Instead of sitting here and saying, oh, I can't do that, they're saying, well, they've given us this software, which isn't just a piece of software. It's a software which allows you to fix it yourself. Revit, AutoCAD, if there's something AutoCAD cannot do. So for instance, if you clicked the integration button in AutoCAD, and it doesn't give you the right integral, you would sit there and go, it doesn't work. It does not work. I could do the hand calc and it doesn't match. And you have no option after that because AutoCAD is a black box tool. You can't fix it. But Grasshopper and all these other things that we're going to use, you can fix. So you can't sit there anymore and stomp your foot and say, this doesn't work, so we'll do things inefficiently. You have to persevere. In this situation, you go, what did he use? Geometry. So he said, I just want to bring in geometry. So you double click here, you say geometry, and now there's that black hexagon emoji, again, something that just contains information. You right click, you say set multiple geometries. I already had something selected, and you guys should notice, right? And set multiple geometries now, they both turn green. Okay? So again, this is chapter 1. Part of chapter 1 is understanding that, just this simple task. What did we talk about? That was 10 minutes just to explain that aspect of things, right? So it's a long road because you need to know this stuff as well as your first principles, and every day it's 10 minutes at a time learning these new skills, right? And learning the idea that if I turn this button on, then I'll only see the stuff that I click. If I turn that button off, I'll see the stuff that I click. So if I hide this, for instance, I still see him, right? He's been hidden. He does not exist in Rhino. This guy, there's nothing being selected in Rhino because nothing's there. The only thing that we are seeing right now on the left is a preview of this guy right here. And the preview changes color because the rules are if you click it, it turns green, and if you don't, it turns red when you're in this mode. But if you're in this mode, you only see it when you click it. And there's various reasons we would use each one. Making sense? Do you guys, Wanling and Jane, do you guys have this up? Do you guys want to make sure that we're following? Byungi as well? So we want this script up, all of us, just follow along, okay? So you want to get, I guess the one thing I'm forgetting is that you guys don't necessarily have this file up. So just go ahead and quickly grab, let's say this, just the rectangle function, right? Or actually just do this. 1, 2, 3, 4, right? And then I would just say, do another one, 1, 2, 3, 4. Then you say poly, join, and now you have a poly surface, right? And you can just copy that, and then you have the data-wise, you will have the exact same thing as me. It doesn't look the same, but data-wise, it's exactly the same. So give that a shot. Do you have Rhino? Don't have to worry about that right now. We're not going to get to that today. I knew we weren't going to get to that today. Do you not have Grasshopper installed?
I just typed in.
Okay, so you don't have Grasshopper installed, so we would need to get that.
Because I used to have it in my old computer, but then they changed it to another one.
I think maybe that we'll just have you kind of follow along then, maybe with Lily. Lily, see if you have it. Is this yours or is this the one Simon gave you?
From
Okay, so maybe you two bunch up on this machine for now, so that we're not wasting time with install. Right, so what we want, again, it's a good point, please make 2 poly surfaces. So you should be able to click on 2 things and see that they're each a poly surface. Okay, Bianchi's got it. Wanling, do you have 2 poly surfaces?
So you see how it says you're in a command right now, just like an AutoCAD, so you just got to escape. So what's this? You just click him. Oh, he's a curve. So you must have used one of these guys. What you want to use is that guy.
No worries, no worries. I know you guys aren't fluent in Rhino, but it's literally the same as what you do in AutoCAD right now, and we're using surfaces, which I know you guys probably are using line work mostly. But the surfaces, like I said, just kind of grab maybe this one, this tool right here, and you can make exactly what I did. No, so you drew two rectangles, right? So let me do exactly what you just did. You did this, right?
Yeah.
And then you did this. All right. So even if we go, let's say you select them, you go surface, and you go planar curves. If you click that, right? Even if you do that, planar curves should be. Oops, I lost it. Planar surface from planar curves. Down, down, down. Look at this screen. Now, did that do anything? You might want to, top tip here, right click this top and go to shaded view, which makes it a lot easier to see what you've done. So now you see how it's not a wireframe view, it's easier to see. There's surfaces. Now here's the thing, Lily. You created a curve, which I can click still here, it's a curve. Now we've created a surface from that, but we had said the data that we have as our example problem, if I click this guy, see at the top here it says polysurface. If you guys know, poly is Latin. It means, whenever you see poly, it means multiple, right? Polynomial and stuff like that. It means multiple variables and stuff like that. So I have, when I click this, a polysurface, which means multiple surfaces. Now you've created here two surfaces. There's not data-wise the exact same thing as what we want to play with. So what I would do if I were you is just sort of, let's say, delete this. You can copy one of them, because what we want is for two of them to converge to one, so it's a polysurface. And to do that, the easiest thing to do is join them, right? So if you just say join, and if I go up here, it tells me what it just did. Oops, oops. So I just said join, and what did he do? He said two surfaces or polysurfaces joined into one polysurface. And now when I click him, he's a polysurface. And then I'm one copy and paste away from sort of having digitally the same thing as the purple.
I guess mine is a polysurface, isn't it? Because I
Click it.
created.
Nope. So what you've done. So again, if I do this, and then I do this, and we had said let's make some surfaces out of that. We know that we have a tool here that says create it from planar curves. And I click this, it's not a polysurface. It's a surface with an opening in it. That's what you've done. Now you could take this, just follow this, just copy it again, and get it over here and then join it. Again, this is an understanding. We're doing chapter 1 right now, by the way. For all of you who don't like the smiley faces, we are literally doing exactly what chapter 1 is. We are learning the difference between different types of data. Because that's why chapter 1 is chapter 1. Because if you don't understand different types of data, you will sit here for hours trying to figure out why something doesn't work just because you don't understand what data is. So just select it. Is that a polysurface? No, because they're not touching, right? So you're trying to join two things which aren't touching. So what you'd want to do, again, polysurface, to use join implies that they're able to be joined. You can't actually join two things that aren't touching each other. So just select one, say move, and then do that.
What about is it
Hmm? All right.
That one actually contains two polysurfaces.
So click this one.
The one?
Do literally the Rhino one. So you're the same thing. You have a surface, not a polysurface.
Oh.
My problem is I can't tap the.
Oh, so so if you can't snap, O snap here at the bottom. It's just like CAD. O snap will help you snap. It will take you a matter of hours if you know CAD.
How can you join together?
Say it again. I'll come over here. All right, so do this. Delete this one. Yeah. And actually, just follow me. We'll do it up here. You got it?
Yes.
Polysurface, right?
Yeah.
So one ling again.
Finally.
Just draw a rectangle. Draw a rectangle, right? Boom, rectangle. You got it?
Every step
Now
feels like a
surface.
barrier to me.
Not
Okay, rectangle.
rectangle for now. Let's all just do that. Rectangle,
Okay.
and then move. Make sure your snap is on.
Yeah.
Move.
Come here.
Oh, sorry. Copy. Sorry. Copy. No big deal. Copy. Then grab both of them. Surface. Planar curves. And what I get? Two surfaces here. And then what do? Join. Okay? So we went from two rectangles. What? Where are you at? Draw a rectangle. You have a rectangle? This guy.
Yes.
Okay, so just copy, grab this guy. He's a surface actually. Right click top here. No, with right click, not left click. Right click and then go shaded. Right?
Oh, okay.
So, but that's a surface, right? We were talking about drawing a rectangle curve.
So that should be polysurface. Polysurface.
Okay. Now, is that a perfect rectangle?
If you use AutoCAD, much more confused. I'm not confused.
Oh snap, right?
It's better you don't know AutoCAD.
You'll be fine. I wouldn't say that.
But if you know
How
AutoCAD,
come?
because
There's no way.
we started drawing from 2D CAD, so for a long time AutoCAD is harder to familiar with. So it's
Now
like
he's a polysurface.
if you're using Windows 10, it's okay.
And now we just
But if you
copy.
jump to Mac iOS, I'm very confused. Same.
We can also
So
use
you have two
three
follows.
colors.
Okay,
If
that's
you
it.
don't know
All right.
Windows, then
So data-wise, we all have somewhere on our screen what we started with. We said there would be two polysurfaces defining this. Now, again, this is a simple example. In reality, maybe our section is made of multiple polysurfaces. For instance, what if we, literally like what I have on the screen right now, what if we wanted to get the moment of inertia of all these guys together, right? But our algorithm is basically based off of two. So let's just say we'll take two at a time here. So everybody, if you have two on your screen, grab the two of them, right-click a geometry bucket. If you don't have a geometry bucket, double-click the canvas and type geometry. Look for the hexagonal, the one that is black hexagon emoji. And click that. And then right-click that and say Set Multiple Geometries. And then what you should be able to do is hover over top of it like I'm doing here and see it saying referenced brep. So right click that guy. So you set multiple geometries and hover over him. You only have one referenced brep. Byungi, you got it?
This one?
Oh, Byungi's got an interesting problem. I'll replicate what Byungi has accidentally done. He's done these two. He said set multiple geometries, and he's come up with reference polyline curves and B reps. So again, it's really important to know a lot about data because everybody calls things different. For instance, over here, if I just click this one thing, hang on. Don't worry.
Where does it go?
Grasshopper, did you minimize him? Just type Grasshopper again. Say, oh no, wait, look. So he's asking you. She's lost Grasshopper. So there's two things here. Right? Two things. One, if you right click here, Grasshopper kind of will disappear if you don't have anything selected. So she goes, where's Grasshopper? Well, look at the command line here, just like in CAD. Look up at the top here, objects to reference. Grasshopper's got it out of your way nicely, so you can click something and then it comes back. All right? Second of all, so just click something and press enter. Okay, this is the big thing. Watch what happens here. If I click over here, it says 1 poly surface and 2 curves added to selection. Why? Because remember, we just went through this with Lily. We created 2 curves, 2 surfaces, and then we made the 2 surfaces into a poly surface. So there are 3 things here, even though we can't see all of them. If I right-click this and I say set multiple geometries, and I hover here, again, hovering tells you what's inside, I see words that are really looking weird to me. Referenced BREP, reference polyline curve, reference polyline curve. Now, here's an interesting fact. Over here, if we asked Rhino, this is the equivalent of us asking Rhino, what is that? And he's told us there are 3 objects. One is called a poly surface, and 2 of them are called curves. The exact same operation we're doing over here, except for when he displays to us what he sees. So that's the exact same thing. We've selected the stuff in Grasshopper. He's saying they are referenced B-reps polyline curves. This Rhino and Grasshopper, they are the same software company. They literally are the same, but even in the same place, they are calling things that are the same. Because a curve is a curve, period, right? They are calling them different English words. So in the left here, it's calling something poly surface and curves. And on the right here, it's calling something, forget about referenced for now. What it means is referenced means it's coming in via Rhino into Grasshopper. It's referenced from Rhino in here. But B-rep, does anybody know what a B-rep is? BREP, you would most likely say? It's a boundary representation, which is effectively a surface or a poly surface. So you see what I mean? If we just focus in on saying surface, the word surface doesn't really mean anything if we're talking about computational engineering, because there's the first principles engineering definition of a surface, then there's the definition of a surface in Rhino, then there's the definition of poly surface, and then in Grasshopper, both the definition of a surface and a poly surface are in one other word, which you guys don't know, English word, a B-rep, which actually stands for boundary representation. This is why it's really, 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 really important to do Chapter 1. I will say it again, because this is where we get you through. And this is the easy one, because Rhino is relatively easy to Revit and stuff like that. If you look at some of the exercises for Revit, they literally use 6 or 7 different English words in one smiley face example. You need to learn 6 or 7 new vocabulary words before you can even get your head around what's going on. Data is the most important thing here. Okay? So Byungi's accidentally grabbed, again, our script. The good news is Byungi should have gone and said, well, what's our plan say? Our plan says we should have 2 surfaces, right, at this point in the time. And if he looks at his thing, he should go, I've pulled in generically geometry. Everything in Grasshopper is geometry, or in Rhino is geometry, right? It's same as CAD. It only does geometry. So he's grabbed everything in the kitchen sink, and he's gotten too much. He should see, what should he see? 2 poly surfaces, and poly surfaces in Grasshopper are called B-reps, right? And they're called something different in Dynamo, and they're called something different in Revit, and they're called something different in your Facade packages and Robot. this is just something you got to know. But what makes learning this way harder is if you don't know the first principles. So if you don't have a plan like this, which states very clearly, this is what I have, this is what I want to do, then you're going to get lost in the weeds of, well, Dynamo calls it this, Grasshopper calls it this. You won't actually understand what it is that when you do stuff, and you know what these scripts look like. They look like this. They always look like we're passing stuff around, right? You won't ever have any semblance of what's going through, what data is going through here. And you will have very difficult time getting to the bottom of that, okay? We're 1 hour in and we've done one little part of our script, okay? All right, so what I'm going to suggest is we can stop there for now, because I know everybody's got to go back to work. I will come in next time, and I'll send you guys a script a little bit ahead of time that gets us the next few steps so that we go through this a little bit faster.
When will be the next?
Next week. So we'll keep doing this. We are still doing the smiley faces. The last few weeks, we haven't been doing them as often because we have projects that are like this, that we're doing it. We are going to do those no matter what. So I highly recommend if you do your doodle, we will invite you to that and you'll get these skills. A key thing to remember is I can make this script, and I'm pretty confident, in like 10 minutes. And we probably will do that just so that we can get some quick, easy wins and save money on our projects, okay? So we probably will do that. But I don't think that's actually what we need to do. Like, we can get that done, but what will happen is eventually you'll have another project that kind of breaks the script, where it doesn't have two poly surfaces, or it has a curve instead of, or it has dirty geometry. So in order for us to have this thing, and what happens if I make this script for you guys, a big black box script, and you don't understand it, and I get hit by a bus tomorrow? What happens then? Because I guarantee you, I'll pull up a script that I've done elsewhere. This is an extremely useful script. This is what an extremely useful script looks like. Full stop. This is what it looks like. And we just spent an hour making this, okay? So we have to work together. There's definitely going to be an aspect of it's more difficult than your skill level right now. But it cannot be that I give you this script and I tell you, here, just all you know how to do is right-click and go select something. Because what will happen for sure is the first thing is this will go red, then all of it will go red, and you'll sit there and you go, oh, it doesn't work. I guess we're going back to AutoCAD to do it old school. What we want is for everybody at this table and over there right now to be able to fix it themselves. And the only way to do that is for us to do it together to as much of a degree as possible. So on this particular project, for instance, I did 80% of the work, right? Over lunches, obviously we can work together completely fine. But if we have a project that we want to bang out a script like this, then we just make a decision. How much does Emilio do? How much do I do? How much is it going to cost? And that's a fee negotiation and stuff like that. But if we don't have that discussion at all, and we just use AutoCAD, we'll only ever use AutoCAD. So next time you have this problem on a job, hopefully within a few lunches, you're getting close enough to where you could maybe spend a couple hours on the job to actually try. Maybe I can come over and help you for a few hours as well. And in that way, you know, how many hours are we spending on this task alone? And this is just the easiest one. The other one is the robot task, which I understand, like getting framing elements and stuff like that, loadings into robot. Again, that's a problem that is completely solved. We are doing it in structural engineering every day, using the BOM. But the problem is we are skills. We're there, but we are separated from there by skills. You guys don't have the skills yet. And the model of, well, then we'll just give it to Emilio is incorrect. We've learned that the hard way a lot of times, because if I leave the company or if I get hit by a bus, then we're in trouble. What we've been talking about this whole year is that everybody should be somewhat skilled in this. So what we're going to work to do in the next few months with these two examples is to get you guys the robot modeling skills and the moment of inertia skills, that you guys don't necessarily need me for everything. And then, going forward, we get to have some very interesting conversations about more even cool project aspects of our job, not just stuff that we spend a lot of time on. Okay, so if everybody's okay with that, I will continue. Actually, can I ask, Bianchi, I don't know if you want to nominate someone or if you want to take the reins on it. Since it's facades and we want to have maximum participation, do one of you guys want to volunteer to sort of organize amongst yourselves for this particular session and to just email Flora and say, we want to do the facade session on Tuesday this week or whatever? I'm happy to do it every day of the week, but I have other sessions, so just pick one day a week for now and we'll do it, and then please try and come to the other sessions.
Okay.
The BH is buying us lunch every day, so yeah, it's easy for us to just show up, spend an hour, and do it. So we have, by the metric of today, and I think Bianchi, for the first time he came to the lessons, I remember it very specifically. First lesson, he put down, I think, one of these. It's no surprise we didn't get anywhere today. But I remember the second lesson, he put down maybe this much. And the third lesson, he put down, this much more, right? So it's slow start, but every day we will continually start to put down more and more things together in one session. To give you an idea of where you're headed, to make a script like this is 2 days. And recall that in each side of these, there's a bunch of other stuff. So when you are doing a job, eventually you'll get good enough to where you're fluent, just like you'd be fluent in Mandarin or Guangdonghua or something like that, right? We're not doing anything here that's that difficult. I promise you that. It's just we need to get some basic knowledge in your head, and you will be doing this exact same thing. Yeah, the clusters are, when you start doing this, you know you're a boss. Okay?
Thank you.
Thanks for coming. Thanks for coming.
This is the